Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning everyone. Today we'll talk about induction. Induction of EMF. Okay, let's say we have a circuit. Okay, a DC circuit. Let's say we have a switch which we can open and close, and we have a coil. And let's say we have a resistor here. Okay, and this is, we call this a primary circuit. Let's say we have another circuit nearby, very close, and it is connected to there is a coil in this circuit which we call secondary circuit, and we have a resistor, another resistor. And let's say we don't have a battery. We have a meter, a voltage meter to measure voltage. Okay, so when we close the switch here, there will be current flowing in this circuit, and as the current is rising in the coil, okay, there will be EMF generated. We follow the Faraday's law. When there is change in the magnetic field or magnetic flux, okay, there will be EMF generated on a conductor nearby within the magnetic field. And so the change in the magnetic field in the coil will cause EMF generated in another coil close by. And it follows Faraday's law. The change in the magnetic flux, the rate of change of magnetic flux will cause generation of EMF in this circuit. And the current will rise until it reaches a certain value, and when it stops rising, there will be no more EMF and current induced in this coil. So the meter, the voltage meter, will rise only for a short while. When the current is stabilized in here, the magnetic flux stabilized in here, there will be no more EMF generated. So that is not quite useful. Let us change this with an AC voltage source where it gives alternating current. So when there is alternating current, the current is always changing. The magnetic flux will also change. Okay? When the magnetic flux is always changing, so EMF will be constantly generated here in the other coil, in the secondary circuit. And there will always be a value of EMF, and also the change in the current, in the voltage, and in the current in this circuit will also generate magnetic field in here, a changing magnetic flux, and that changing magnetic flux in this coil will in turn generate magnetic field in the other coil. So there is mutual induction of EMF in both coils. The changing current in this coil induce current in here. The changing current in the second coil, in the secondary circuit, will also induce current in the first coil. So there is mutual inductance. And because of the negative sign there, that means the voltage generated here will be in reverse to in the reverse direction to the voltage or the current that is flowing in the first circuit. And also that is mutual induction. What is self-induction? Self-induction is we have only one circuit. let's say we have one circuit here, and there is one coil. The change in the current here, will change the magnetic field, and that magnetic field also generate EMF in the same coil. So in effect, it will reduce the current that is flowing in the coil. So the current will rise slower through the coil. If we compare, if there is no coil, just a straight wire, the current will rise faster. Okay, because of the self-induction, this is called self-induction, the current rise will be slower. Okay, thank you.